So let's apply our reduction laws. Who wants to do this one? Who wants to try this one? Savika, do you want to try this one?
Okay.
So what are the 3 steps? Do you remember the 3 steps?
The quadrant.
Then number 2 is positive or negative. And number 3 is 180, 360. Same. 270, 90, it changes to the co-ratio. So sine 180 minus x is going to be?
Sine x.
Sine x. Okay, great. And okay, this is a tough one. Who wants to do this one? The next one, minus 180 plus x. Anybody want to try that one?
Negative cos x.
Say it again.
Wait, negative cos squared x.
Why do you say that?
Because if you add 360 to negative 180, then it gives you positive 180. And then
So Nafisa's adding 360 to make it positive. That's a nice idea. So it's 180 plus x, right?
And then 180 plus x is in the 3rd quadrant, and cos is negative in that quadrant. So,
and then it's squared.
Oh, then
So
cos. Wait, if you square, then the sign, the negative sign falls out.
So it's just going to be cos squared x.
Cos squared x, yeah.
Yeah, and then cos 35. We can't really do much to that. Okay. And then tan 540 minus x. What can we do there? Amaro?
So we say 540 minus 360, that's 180. And 180 minus x is in the 2nd quadrant, so it's negative tan of x.
So you said 360 minus 180, so it becomes 180 minus, right? So then it's, negative tan x, right? We probably might have to convert tan to sine of the cos. Sine 235, what's that going to be? Anybody want to try that one?
A negative sine 35.
So you must tell me how you got that.
270 minus 235.
Right. Okay. So it's, do you guys see how she's linking the angles with what you've got here, right? So you're probably gonna have to cancel. So 270 minus 35, but that's gonna be, which quadrant is that in?
3rd.
3rd, and it's so it won't be sine 35, eh?
It will be negative sine 35.
No,
Won't
it's
it be
270.
cos?
It's 270, so it's gonna be cos.
Oh, cos. Negative cos
Okay.
35.
Couldn't I just do sine 180 plus 55?
You could, but remember you've got a 35 here. So I'm thinking let's keep the 35.
Okay.
So that we can cancel. But either way is fine. So this is going to be cos 35. Negative cos 35. Yeah, so it's 3rd quadrant, so sine is negative. And it's going to be changed, so it's going to be minus cos. So this will be positive here, right? Cos 35. And then sine of 90 minus x is just going to be?
Cos of x.
Cos x.
1st quadrant, Sine is positive in the first quadrant, and it's 90, so it changes to cos. So what can we do now?
Wait, I'm a bit
The 10 can
confused
sine over
about.
Nafisa just said, was there something that
I'm
wasn't
not
clear?
Yeah, the cos 35. Why is it positive?
It's negative, but this was negative over here, so then it becomes positive.
The 10 was negative, so you're saying that times that.
Yes,
Oh,
it was negative 10, and then because you've got negative cos 35, then it becomes positive.
okay.
Okay. The cos can cancel. This can cancel. So you're left with sine x cos x over
Sine over cos.
but it's over tan x, right? But what it's 1
Yeah,
over
you can
tan x. So how can we simplify? What's 1 over tan x equal to?
Cos over sine.
Cos of a sine. Because tan is sine of a cos, but here you've got 1 over tan, right? Because remember there's a 1 over tan. So that's going to be cos of a sine. So what happens?
Doesn't it cancel?
So you're left with cos squared x, which is single trigonometric ratio. Okay. And then it says, okay, now we have to simplify again. 43 and 47.
What?
Question 2.2.
I didn't
Okay.
get the
What was I say it again?
first step. I didn't get.
Okay.
Yes, please.
So then it just becomes cos squared x.
Oh, okay.
Okay. Everybody happy?
Yes.
Yeah.
Okay. Then the next one, 2.2, tan 43, sine 47. Okay. So because they don't want you to use a calculator, we're probably gonna have to simplify this, right? Using reduction. Can we simplify tan 43?
You say sine 43 over cos 43.
Yeah, so you can. For now, I'm going to leave this over here for last. I always prefer to deal with tan at the end because I know it. Yeah, I mean, just because it just makes it like it's a fraction. So always just leave that for the end. But sine 47, you can't really change. But what's interesting between 43 and 47? What's interesting about those two numbers?
They both are in the first quadrant. They're both acute angles. I don't know.
Yes, but something more.
Isn't if you like take 90 minus 47, then you'll get 43.
So they add up to 90.
Yes.
Yeah.
So maybe that's something that, for me, that's just sticking out, and we're probably gonna have to use it somehow, right? So just keep that in the back of your mind. So when you're reading these questions, just look for different patterns. So here I'm looking, okay, this is probably gonna have to link up somehow. What about cos 137?
180 minus 43 gives you
Correct.
137.
So how can we reduce cos 137?
180 minus 43.
And what's that gonna be?
43.
Negative cos 43, I think.
Yes. Correct. So we've got 10, and that's interesting. Correct. It's a tan 43, sine 47, and it's minus, so it's going to be minus cos 43, right? So we can maybe bring the 2 in front, so it's cos 43.
Wait,
Because remember,
what?
There's a 2 here, right? So let's just bring that in front.
Oh, right. Okay.
Okay. What about cos 317?
But why is it
360 minus
minus now?
43.
Because cos
Because
137 is minus cos 37. Minus cos 43.
Okay.
Okay, and then cos 317.
360
2
minus
cos
43 gives you 317.
Right. You guys see how you're linking it now? You guys are making the connections between the different angles.
Yeah.
So you see, this is what they want you to do. They want you to make these connections. And what is cos of 360 minus 43?
Oh,
cos 43.
Just cos 43.
yeah.
So then you've got something to cancel in the numerator. Okay.
Mm.
What about sine 133?
180 minus 47 gives you 133.
So that's sine of 180 minus 47. So what's that going to be equal to?
Sine 47.
Sine
Mm.
47. Yeah. Minus 1.
Yeah.
Oh my goodness. Look at it.
I see a
Contain-
double identity, but I don't want to change it now because.
Where do you see the double? Where do you see the double
Oh
identity?
no, sorry, no, it's not.
Oh, wow. Say it again.
Wait, I do see it.
Wait.
I think at the
It's a
But
double.
I
the
don't
cos
know.
is squared in the identity, but in this question it's not. It's 2 cos squared minus, actually, never mind, I don't know.
No, but if we would have just changed the sign with cos, so it would have been 2 sine 47 cos of 43, and that is sine of 2a. Oh, never mind.
Yeah.
You're nearly there.
Yes.
You're nearly there. You must change. What if you change this to cos 43? Can't you change this to cos 43? Sine 47.
You use
Sure.
90.
Yeah.
Yes.
Then it becomes 2 cos squared minus 1.
Mm-hmm.
And then
Right.
that's equal to 2 cos 2
Oh, okay.
theta.
You guys hear that? But let's just hold on. Let's just hold on. Let's just do the other side first. So we've got a 10. So this, because this is 2 terms here. Do you see that? There's 2 terms here.
Yeah.
This is not like this where you can just cancel. You have to be careful.
Yeah.
So maybe you have to deal with the numerator first. Okay. So let's deal with the numerator. So this is sine 43. Yeah, I mean, isn't sine 47 just cos 43?
Yes.
So can't this be cos
what?
43 squared?
Yes.
Sine 47 is cos 43. Do you see that?
No.
Yes.
Sine
Yeah,
47.
no.
Sine 47 is equal to cos 43 because it's 90 minus.
Oh, yes.
Oh,
Sine
okay.
47 is sine of 90 minus 43.
Yes.
So therefore, sine 47 is cos 43, which gives us cos 43 squared, not so.
Oh, okay.
Cos 43 squared. Okay. Right now, what can we do next?
The 10.
What can we do to the 10?
The sine of
Change it to sine over cos.
Sine of a cos, right? So it's going to be sine 43 over cos 43. What happens?
The one cos 43 cancels with the bottom one.
So you're going to be left with,
Negative 2 sine 43 cos 43. Oh, I see it.
Then that's sine of 2a.
yes.
That one. Oh,
Yeah.
So it's going to be minus 2 sine of 86, right?
Yes.
yeah.
And what's the bottom?
The bottom.
Wait, do we need
You-
to change?
You change the sine 43 to cos 40, sorry, sine 47 to cos 43. Then you say 2 cos
43.
squared 43 minus 1, which is equal
Oh.
to cos 2.
But then that's not
It is.
It
That's
is.
oh yeah, right.
So
2
therefore,
cos minus 1
Cause
cos of 86, sorry.
and how can we simplify this?
Ha, you
it will
said
be
tan
negative
86. Okay.
2.
Oh, you can say. Oh, wow, mind blown.
And that's the answer because they wanted it as a single trigonometric ratio.
Issue.
So do you see, we haven't done fancy maths here. All we've done is we've applied reduction, applied reduction, applied reduction. And because we knew our formulas, you see, that's why you have to memorize the formula. Because you see, if you knew the formula was 2 cos squared minus, then you'll be like, okay, I've got that here. I've got that here. So maybe, you know, that's why if you rely on the formula sheet, then you might miss these things. You see? Do you guys see that?
Yeah.
Okay. Let's do the optimization. Amara, did you manage to watch those optimization videos on the bank?
Not all of them, but I tried one. I think it was yesterday.
Because it's 16, so you've got lots of stuff to go through to keep you busy if you need to.
Yeah.
Because the thing is with the bank, it's lots of optimization questions. So you can try it and then you will see the explanation. And then once you try it, you will start seeing patterns. You will start seeing patterns. And that's how you become stronger. Okay, so then, an industrial process requires water to flow through its system as part of the cooling cycle. Okay, cool. Water flows continuously, cool, for a certain period of time. The relationship between time, okay, so the relationship, remember functions are just relationships, not, you know what I mean. When the water starts flowing and the rate. Okay. So R is the rate and T is the time.
Time.
So it's very important to understand what does the equation actually mean. So if I sub in a particular time value, at that time, this equation will tell me the rate of flow. Do you guys see that?
Yes.
So that's why it's always important to understand the equations. Naima, you watched that movie, eh? Nafisa, Naima watched that
Yes.
movie, The Man in New Infinity. She said it was very nice.
Yeah.
So that's why you have to understand your equations because they have meaning. So so what does this equation mean? It just means if I choose a particular t value, this equation is going to tell me the rate of flow at that t value. Okay. Amaru, does it make sense? The equation.
Yeah.
So now the question is, how long will it be at a maximum rate?
Find derivative and make it equal to 0.
Right, because this is an equation for rate. and you want the maximum rate. And the way you find the maximum, you make the derivative naught. Do you see that?
Yeah.
Nafisa? Ayan? Was it Ayan? Nafisa?
Yeah, I understand.
Okay. So what's the derivative?
Minus 2/5 plus 10, I think.
Minus 4/10. What did you get?
No, I said negative 2/5 t plus 10.
Which is 4/10. Yeah, 2/5 is 4/10. Yeah. Okay. So minus 2/5 t plus 10. Yeah. Equals
Put 0. Yeah,
equals
equals
0,
to
right?
0.
Great.
Yes.
Because you want the derivative, want the maximum, so you make it equal to 0. So what can we do now?
Then take 10 over.
Yeah.
So it will
So
become
it's
negative 10.
wait, make it 2/5 t equals 10. It's easier. Just take the 2/5 t over. Then it's positive.
Okay.
Okay.
Yeah, then we divide by 2/5.
Yeah. So that's the same as timesing by 5/2,
So
which is
25.
25. Which is 25.
Yeah.
Yeah. So that means after 25, let's say seconds.
Yeah.
Where does it say seconds? Oh,
Like t is
yeah,
measured
yeah,
in seconds.
yeah. So after 25 seconds, it's the maximum. Is 25 the maximum, by the way? Is 25 the maximum?
Isn't it? It's the x value at which it's maximum.
Yes, that's very important. Well done. Because this question is asking you how long will it be a maximum? It's not asking you what is the maximum. If it asks you for the maximum, you would take this 25 and sub it in.
The original.
Do you guys see that? You see how there's two types of questions. It's this one, and the second one will be what is the maximum?
Yeah.
Okay. 10.2. After how many seconds will it stop flowing? Sure. So what are they asking you? Now that you understand what the equation means, what does it mean when they say after how many seconds does it stop flowing? This is English. Now, Rivka's mic isn't working, but this is English. So now we need to translate this into maths.
We need to calculate for t, but
Yeah, they say after how many seconds, so they want t.
So
But
you
what?
sub back in number 1 into the second. I don't know.
but why one?
What's the key word in the sentence? What's the key in this?
How
Hey,
many
Jan?
seconds?
No. Mhm.
Seconds. So they want you to work out t. So what is t?
But
Yes.
t for what? T for what?
Stop of the flow.
The stop of the flow. That's the key word, the key phrase.
But how do we figure that out? Like,
What does it mean when it stops flowing? What does that mean for the equation? In the equation,
0.
there will be no r. I mean, like, there will be no rate at which it's flowing because it's not
therefore,
flowing.
therefore,
Oh, r will be 0.
R is 0.
Ah, okay.
So you guys were right when you said solve for t, but you're not telling me what must I do for r.
Mm.
It stops flowing. If it stops flowing, what does that mean for the rate?
Yeah.
There's no rate. How can it be flowing if there's no rate? How can there be a rate if there's no flow? So therefore r is 0. Do you guys see that?
Yeah.
Yeah.
So do you see how important it is to understand your equation
Yeah.
and understand the mechanics of the equation? Okay. So what type of graph is this, by the way?
Okay, but that's the answer.
No, we
Like,
haven't found the answer
that's
yet.
fine.
I haven't said, I'm just asking you, so what type of graph is this?
A parabola.
Okay, wait.
What type of graph? What type of parabola?
A frowning parabola.
Okay, so it's probably
Yeah.
gonna be like this, right? Okay. So when we solving, when we make r naught, we're finding the x-intercept, right? Because we're making y naught. So we're
Yeah.
finding that basically. So this is the time when the r is naught, the y value. Okay. So let's make y naught. So it becomes naught equals minus 0.2 t squared plus 10t. Factorize t.
Mm.
Actually, this graph does this, to be honest. Does this. The graph does this. Okay. We factorize t, right? We can divide by negative 0.2, whatever. No, yeah, we can actually. Yeah, we can. Do you guys want to divide by negative 0.2?
Yeah.
Yeah.
Okay, so it's 50, right? For t squared plus minus 50t.
Yes.
Minus 50.
Then we took out t as a common factor, I think. Yeah.
So therefore
Oh,
t
yes.
equals
0 and 50.
0 or t equals to 50.
So what does this mean? That you're getting two answers
At both those times.
at both those times. What?
The water stops
The
flowing.
water will stop flowing.
Yeah, because I mean, if you think about it, when you started, right? I mean, there's no flow in any case at the start, right? When t is naught. So you only turn on
Yes.
the
Yeah.
machine at t naught. You guys see that?
Yeah.
So that's why it makes sense that at t equals naught, there's no flow. But your answer will be t equals 50. Okay. So do you see how just understanding what the equation means is so important to answering the question? Okay. So it's 5 to 5, and I do actually have to go with 5. But Nafisa, I will answer your questions later on if it's okay.
Okay, it's fine. You can answer them and send it to me.
Yeah, because then I'll make a video for those ones. Okay. So do you guys have any other questions in the meanwhile? Because we have about 3 minutes. It's not enough time to do those other questions.
No.
No.
Okay. Also, so for me, campus is just a little bit hectic at the moment. So I've changed it to just once a week for the time being. Okay. So just on Thursdays.
Okay.
Which is fine because you can still ask questions throughout the week, right? You can still ask questions. It's not like you have to wait for the study session to ask me. It's just like the live sessions.
Yeah, but the live sessions are like better, but it's okay. It's okay.
Well, I mean, I think we're doing the same thing if you think about it, because if you ask a
No, you
question,
get to like engage, yeah,
but you
better.
can still engage on that thing, because you can say, I didn't understand this part of your explanation, or. But I get what you're saying. It's not live.
Yeah, it's not the same.
Yeah, but I mean, it's very close, because remember, it's very close, because there's lots of other tutors who want to help, and you must make use of that, because you've got like 15 tutors. So
Wow.
you must make use of it, because, and the nice thing is, like, it's a personal chat basically. You're not asking the group anymore, so you don't have to worry about like people getting upset with the notifications that you're sending, because it's a personal chat now. You guys know that, right? It's a personal chat
Yeah.
now. So you can ask as many things as you can, as you want to. That's what we want. We want students to engage, and I believe that you can still engage even without this live session. The live session is actually just an extra thing that we thought would be nice, but we actually think you can engage from asking us questions on, like, you can even send voice notes and say, look, but like, why is r equal to 0 in the memo, or can you check my working out for this question? So things like that, so you can definitely make use of that platform. And also for me personally, when I go back to campus and it's contact teaching, it will be a bit challenging to do this, you know what I mean? So in that case, the questions which you send to me on that platform is actually easier, if you get what I'm saying.
Yeah.
But the thing is, you guys can still engage. You can, like, it's a conversation, right? It's not supposed to be just question answer. No, you must actually have a conversation. And we're actually working on developing a platform where, like, whoever's online, tutors can just like almost take you to a separate chat where you have like a specific conversation with the tutor. But that's basically how Tutonic was designed. I mean, this live session is a new thing, and I actually think that having the questions where you ask them, it means that if you get a response, it's a video that you can watch over and over again, and you can ask questions. And the nice thing, you can ask the question any time of the day. The live session, you have to wait. I mean, once somebody asked a question at 2:00 in the morning, and luckily I was awake. Now, once I actually made a video in bed. Once I made a video in bed, actually, because I was lying in bed, and then my iPad was next to me, and first I asked the question, I'm like, damn, man, I don't want to do this tomorrow morning. So then I lay in bed, and I was like answering the question on the iPad on my side. And that's the cool thing about the whole Tutonic process, is that you can ask your question anytime. The tutor can look at the question and support you like that. So you must make use of it. Think of it as a conversation. Okay.
Yeah.
So that's what we encourage. And obviously it's anonymous now, so you don't get like, you have to worry about people, because the groups are becoming bigger. You can see like more and more people are joining, right? You probably get those notifications. So we really don't want students to feel uncomfortable asking questions, because also in the live session you're with other students too, right?
Mm-hmm.
Right, you're with other students in the live session, right?
Yeah.
So even though you guys are, I'm assuming you're becoming more comfortable with each other, the interaction is still not personal in a sense. Whereas when you ask a question, it will be more personal. Even though we forward the video, but you notice that we try to not mention the names anymore. Like, we don't forward your message, we share the message. You probably would have noticed that, right? Like,
Mm-hmm.
so if you send us a picture, we won't forward it to the group, because if we forward it, it will say your name. Right.
Yeah.
So we share the picture so that it doesn't say you sent the picture, but then everybody else still benefits, you see. And that's also the other benefit of the live session, is that of the asking questions, because then everybody gets the video, whereas in the live session it's just the people who were actually at the live, even though we send the video afterwards. But yeah. Anyway, it is 5 o'clock. I will send you your other stuff, Nafisa, later on, and yeah, I'll see you guys on next week Thursday.
Okay.
You have any other questions? Anything you want to say?
No.
Okay. See you guys. Assalamualaikum.
Bye.
Bye.
Salam, shukran for the lesson.
See you.